Hi, this is Dr. Liang Ding. This lecture is for Chapter 2, The Economic Problem. In this chapter, we have 4 sessions. The first session is to define the production possibilities frontier and use it to calculate opportunity cost. The second session is to define preference and marginal benefit and describe an efficient allocation of resources. The third session is to explain how specialization and trade make resource use more efficient. The fourth session is to describe the economic institutions that coordinate decisions. In this chapter, we will study an economic model that answers the following questions. How do we know when we are using our resources efficiently? How can we become more productive? Is it really true that both buyers and sellers gain from trade? First, let's look at the production possibilities frontier, PPF. The production possibilities frontier is the boundary between those combinations of goods and services that can be produced and those that cannot. To illustrate the PPF, we look at a model economy in which the quantity produced of only 2 goods change, while the quantity produced of all the other goods and services remain the same. Let's look at the production probabilities frontier for cola and pizza, which represents any pair of goods and services. The production probabilities frontier for cola and pizza shows the limits to the production of these 2 goods, given the total resources and technology available to produce them. This figure shows this production probability frontier. The table lists the combination of the quantities of pizza and cola that can be produced in a month, and the figure graphs those combinations. The x-axis shows the quantity of pizza produced, and the y-axis shows the quantity of cola produced. We can produce at any point inside the PPF or on the PPF. Those points are attainable. For example, we can produce 4 million pizza and 5 million cans of cola. The figure shows this combination as point E and as possibility E in the table. Moving along the PPF from point E to point D, we produce more cola and less pizza. 9 million cans of cola and 3 million pizzas. Or moving in the opposite direction, from point E to point F. We produce more pizza and less cola. 5 million pizzas and no Coke. We achieved production efficiency if we produce goods and services at the lowest possible cost. This outcome occurs at all the points on the PPF. The points inside PPF, production is inefficient because we are giving up more than necessary of one good to produce a given quantity of the other good. Any point inside the frontier, such as Z, is inefficient. At such a point, it is possible to produce more of one good without producing less of the other good. At the point Z, resources are either unemployed or misallocated. Each choice along the PPF involves a trade-off. On this PPF, we must give up some cola to get more pizzas, or we must give up some pizza to get more cola. Trade-offs like that between cola and pizza arises in every imaginable real-world situation in which a choice must be made. At any given time, we have a fixed amount of labor, land, capital, and entrepreneurship, and a given state of technology. We can employ those resources and technology to produce goods and services, but we are limited in what we can produce. All the trade-offs we've just considered involve a cost, an opportunity cost. As we move down along the PPF, we produce more pizzas, but the quantity of cola we can produce decreases. The opportunity cost of a pizza is the cola foregone. The opportunity cost of an action is the highest valued alternative foregone. The PPF makes this idea precise and enables us to calculate opportunity cost. Along the PPF, there are only two goods, so there is only one alternative foregone. Some quantity of the other good. To produce more pizzas, we must produce less cola. The opportunity cost of producing an additional pizza is the cola we must forego. Similarly, the opportunity cost of producing an additional can of Coke is the quantity of pizza we must forego. If we move from F to E, the quantity of cola increases by 5 million cans. The quantity of pizzas decreases by 1 million. Therefore, the opportunity cost of the first 5 million cans of cola is 1 million pizzas. One of these cans of cola cost 1/5 of a pizza. Opportunity cost is a ratio. It is the decrease in the quantity produced of one good divided by the increase in the quantity produced of another good as we move along the production possibilities frontier. Because opportunity cost is a ratio, the opportunity cost of producing an additional can of cola is equal to the inverse of the opportunity cost of producing an additional pizza. Therefore, when we move from F to E, the opportunity cost of one pizza is 5 cans of cola. 1 can of cola costs 1/5 of a pizza. Because resources are not equally productive in all activities, the PPF bows outward. The outward bowed shape of the PPF reflects increasing opportunity cost. That is, the opportunity cost of a pizza increases as the quantity of pizzas produced increased. When we produce a large quantity of cola and a small quantity of pizza between point A and B, the frontier has a gentle slope. An increase in the quantity of pizza causes a small decrease in the quantity of Coke. That is, the opportunity cost of a pizza is a small quantity of Coke. When we produce a large quantity of pizzas and a small quantity of Coke between the point E and F, the frontier is steep. A given increase in the quantity of pizzas causes a large decrease in the quantity of Coke. So the opportunity cost of a pizza is a large quantity of Coke. Next, our questions are: how do we choose among the points on the PPF? How do we know which point is best? That's the end of session 1.